Our company, Carver Scientific, through the SBIR process, is working on an advanced non-electrochemical energy storage technology. Our energy storage technology is a device we refer to as an EESD. EESD is an acronym for Entropic Energy Storage Device. All of us at Carver Scientific share a great hope for the future of energy. We hope you find our discussions and plans of interest. Our company has a technical focus across a range of operationally, economically, and environmentally superior energy storage technologies. We have approximately 20 domestic patents relevant to energy storage. Our company has benefited from 6 SBIR contracts, 2 of which remain in progress. About 40% of our funding to date has been through the SBIR process. Investor funding, commercial revenues, and other revenue sources have funded the balance of our research. Of note, our SBIR objective to achieve 2 times or greater the energy density relative to lithium-ion battery technology should be of particular interest. We believe this milestone will define a new paradigm for energy storage. In this presentation, we will cover how we go about achieving that. While the energy and power technology community of interest has a clear demand for higher energy density, other attributes such as safety, charge rates, discharge rates, control systems, and many other attributes often refine and further define user requirements. We utilize this slide as a visualization tool. Parties interested in energy storage can quickly form a preliminary assessment of an EESD against lithium-ion technology across a set of relevant attributes. At a glance, one can quickly assess a set of attributes typically of interest to users of an energy storage technology. Please consider points on these charts as indicators of relative preference, not as measurable data points. In the chart, the green outer ring represents our long-term targets for relative performance of an EESD. We believe the technology offers great opportunity. Fully achieving superior positioning along the outermost margin of the ring will require additional funding. The red line represents our assessment of the current positioning of lithium-ion technology. The blue line indicates our assessment of the relative position of the EESD contemplated in our current SBIR effort. Should you draw a comparison between an EESD, represented by the blue line, and lithium-ion, represented by the red line, you immediately note a few items. With safety, many users have concerns surrounding the risk of thermal runaway events. In the case of an EESD, the primary active material is an organic material not susceptible to thermal runaway, thus naturally providing the opportunity for a superior safety profile. Regarding charge rate and discharge rate, the storage mechanism in an EESD is a capacitive energy storage mechanism. This mechanism is broadly recognized as having a rapid charge and powerful discharge profile. Arrows on this chart highlight our currently trending efforts. For example, we are trending in the direction of significantly higher energy density. This will be discussed in greater detail in the next slide. The spread between the green outer ring, EESD's long-term opportunity, and the blue inner ring, our current SBIR targets, indicate our assessment of the relative opportunity to further improve the EESD technology. As with any nascent energy storage technology, with appropriate funding, significant opportunity for a broad set of improvements remains. Here we show representative components of our energy storage technology. As mentioned earlier, we refer to this device as an EESD. EESD is an acronym for Entropic Energy Storage Device. We use the term entropic because it describes the mechanism within the cells where large, complex organic molecules organize themselves or disorganize themselves in the presence of an E field. The organic molecule we utilize is a derivatized version of zyme. Zyme is a long and complex naturally occurring protein found in corn. It is hypothesized that in the presence of an E field, each derivatized structure acts as a lever against the larger structural backbone of the protein. The many derivatized groupings each provide the opportunity to store a small amount of energy in the bond angles between each derivatized group and the protein's backbone structure. As the E field within the EESD strengthens, bond angles are torqued and energy is stored. Each grouping then returns this small amount of energy as the EESD discharges against a load. This entropic energy storage occurs within the green cells shown. Additionally, it should be noted that these cells can be shaped, formed, or constructed to any reasonable size or shape. Customization of the form factor is therefore feasible. Another item distinguishing our technology from typical battery technology is that it is a device, with the D in EESD standing for device. In our case, the device being comprised of entropic energy storage cells, a set of controls, and a licensable proprietary charging mechanism. Here, the charging mechanism is unique. It is the introduction of an ability to continually charge the device paired with the ability to store energy that permits the EESD to outperform energy densities attributable to lithium-ion technology. The paradigm of electrical energy storage will shift from being just energy storage to that of a device that can generate, manage, and store electrical energy. In an EESD, through the benefit of time, an extended electrical energy supply can be generated and stored, hence a basis around which a new energy storage paradigm is formed. It is worth repeating, with the benefit of time, the internal charging mechanism within an EESD can enable the energy output of an EESD to greatly exceed the energy output of lithium-ion batteries. Said differently, an EESD of a given mass can have a higher apparent energy density than a lithium-ion battery of similar mass, all as measured by total energy output of each relative to total mass of each. Here, I will discuss a high-level overview of a potential structure for the future of energy. Our plans for the EESD are informed by this view, including an understanding of the magnitude of today's energy markets and the knowledge that the economic inertia of today's energy markets is nearly insurmountable for a small company such as ours. We need a different strategy. We understand that disruption as a strategy likely will fail, whereas complementing the interests of large participants in today's energy markets is a more likely path to success for our EESD. A quick review of the top layer of the chart indicates our viewpoint that scientific innovation and business model innovation in combination with each other will define the new opportunities within any energy transition. We believe Carver Scientific and our EESD technology will contribute to opportunities an energy transition will enable. The next layer in this chart restates our belief that today's enormous players in the energy markets, large energy companies, financial institutions, and others, likely will also be the relevant players and the economic winners in both the energy transition and in the future of energy. These are the companies we must identify and share a preferable economic solution with. Next, it is important to note there will not be a one-size-fits-all solution. Rather, each industry will have their own requirements, needs, and timelines. Further development efforts for the EESD must address these differing needs. In a final layer resides our plan for a new energy marketplace. A foundational assumption is that we must give the EESD a superior economic house, and that home must also provide room for all of today's large energy market participants. Remember, our EESD incorporates a charging mechanism. Energy generated by the EESD has a real economic value, and we intend to work with partners so that we each benefit from an ability to monetize the value of this energy. Utilizing the efficiency of existing cloud-based technologies, the measured value of energy generated, managed, and stored at a fully distributed product level can be linked with a centralized marketplace where the energy is monetized. We intend to introduce a cloud-based energy marketplace, a business model where decentralized energy generation and decentralized energy storage benefit from an overwhelming business preference for direct linkage with centralized economics. This will be enabled through a new cloud-based energy marketplace. So enough about the breadth of our long-term vision. How do we, as a smaller SBIR company, proceed so that our initial steps remain compatible with this longer-term vision? First, it is our intent to license the EESD technology to manufacturers that will produce drop-in compatible format EESDs. These EESDs could compete immediately with the convenience of higher energy density and a superior safety profile being the primary differentiating factors. We have a direct interest in speaking with manufacturers interested in licensing, manufacturing, and distributing our EESD technology. Secondly, we will address differing concerns across industry segments by licensing the right to design and manufacture customized solutions directly into their industry-specific products. We are particularly interested in speaking with entities that additionally express an interest in participating economically in our contemplated marketplace. At a higher level, we also hope to have the opportunity to both publicly and privately champion the EESD as an economically favored energy storage solution. We are interested in speaking with participants in the energy and power technology community of interest. We welcome all direct interest in further funding the advancement of the EESD. We welcome all interest from manufacturers that hope to license, manufacture, and distribute a next generation of energy storage technology. We welcome all interest from product companies hoping to design and incorporate EESD capabilities directly into their products. On behalf of all those at Carver Scientific, we thank you for your interest. Please feel free to contact us.